So here's a question that can be a bit rough if you do not know the trick of partial fraction decomposition. So this is an integral in which we're going to split up this integrand into smaller fractions. And the process of splitting it into smaller fractions is called partial fraction decomposition. So evaluate the integral of x plus 3, everything divide by into bracket 1 plus x, into bracket 1 plus x squared dx. So let's see how we go about this problem. All right, so let's see. So this is called partial fraction decomposition. If we are going to do that, we need to remember how to, add fractions together. So we're going to write this bigger fraction into two fractions with two denominators. One will have a denominator 1 plus x, which is this one here. The other one will have a denominator of 1 plus x squared. So I'm going to add that there. But what we want to understand is that when we write this as fractions, if this is a polynomial of order 1, then this has to be order 0, effectively saying that this needs to be a constant. So we're going to put a constant here and put as a constant divide by 1 plus x. And then we're going to add another constant, so a numerator over 1 plus x squared. Now you notice in this case the numerator is bx plus c, and the reason we do that is because the denominator is a polynomial of order 2. So if the denominator is the second order polynomial, then we want the numerator to be a first order polynomial. If the denominator is a first order polynomial, then this should be a 0 order, although we don't really have a 0 order polynomial, but effectively we are saying that we have a constant. So this is x power 0, when this is x, highest power here is x power 1. This is highest order x power 1 if the denominator has a highest order of x power 2. So we are going to express this like this, and our job is to find the value of a, b, and c that makes the left-hand side be equal to this right-hand side. Okay, so that will make this be the same as this. So if we're going to do that, we need to first of all combine this back together. Now we know that if I have a over b plus c over d, then I can combine these two fractions by simply multiplying the denominator, b times d, all right? And we do that because what we're going to say is we multiply this by d, and so if we multiply this by d, then we have to multiply the numerator by d. I don't want to spend too much time on this. Multiply this by d, and so the numerator must be multiplied by d, all right? Multiply this by b, so the numerator must be multiplied by b, and so db in the denominator, so the fractions have the same denominator, so we can add the numerators and we end up with a d plus c b, like that. All right, so this is the same thing that we want to do with this. Okay, let's see how what we end up with when we do that. Right, so we combine the right-hand side, and then we are going to equate it with the left-hand side as it is there. So if we do that, we simply get the denominator becomes the 2 multiplied together, just like that, and the numerator ends up being a times 1 plus x squared plus bx plus c multiplied by 1 plus x, like that, the same way that we added those two fractions. And so this is what we have. Now, since these two fractions are equal and the denominators are the same, it follows that the numerator there must be the same as the numerator on this side. Okay, so the numerators must be the same if the denominators are equal. So we can write that x plus 3, which is this one here, must be equal to a into 1 plus x squared plus bx plus c into 1 plus x. So this needs to be true, or has to be true, if the denominators are the same and if we are equating them. Now we're going to use this expression. I could have done this in one step really. We don't really have to be doing this. We can look straight here and say I'm going to have a times that and the numerator here multiplied by that, and I will equate that to that. So I don't need to do all this. Well, if you know how to decompose fractions into partial fractions, then you know the process is a bit faster than this. But let's do this for anyone who may not have done this before. All right. Now, to find a, b, and c, there are two methods we can use. One method is simply to open the brackets. So we'll have coefficients of x squared, coefficient of x, and a constant. And then we equate the coefficient of x squared on the left-hand side with those on the right, the coefficients of x on the left-hand side with those on the right, and so on. But that process can be, sometimes can be harder than a much simpler method. In this case, the better method to use is what we're going to do here. And that is, I am positioning this in a table. So I hope you can see I've drawn a horizontal line there, and I'm going to draw another vertical one there. Okay, and what I'm going to do is I'm going to pick up, select values of x appropriately so that they will help me determine the constant, all right? So I deliberately want to pick certain values of x. If I make x be equal to 0 and substituting on the left and the right hand side, so the first one here gives me, substitute 0 here, then I get 3 on the left hand side there. Okay, and if I put 0 here, I get a times 1 and substitute 0, so this disappears and I'm left with c in this bracket. Put 0 there and I'm left with 1 in this bracket, so c times 1 is c. So substituting 0 gives me 3 equals a plus c. All right, now I want to substitute 1, and the reason is that I want to get rid of this term here. If I put negative 1 here, then this is 1 minus 1, which becomes 0. This term disappears, and then I'm able to work with that. So let's make x be equal to negative 1. So if I do that, the left-hand side there, negative 1 gives me 2 here. If I put negative 1 there, put negative 1 here. Negative 1 into bracket squared is just 1. 1 plus 1 is 2, so this is 2a. All right, so the first term on the right is 2a. And I'm putting negative 1. Negative 1 placed here renders all this 0. And that is the intention of choosing my negative 1 there. So I can get rid of b and c to help me determine a. So that term becomes 0. So clearly we can see from here that the value of a has to be equal to 1. Right? 2 equals 2a, so a has to be equal to 1. And since I know a now, I can go back to my first line there. A is now 1, so c has to be 3 minus 1, which is 2. So now I know that my value of c is 2. I am left to find the value of b. Okay, so what I'm going to do now is to choose another value of x. So if we let x be 1, ideally, you want to choose as small integers as possible, right? So let's make x be equal to 1 and substitute. If I do that, make it 1 now. All right, that gives me 4 on the left-hand side. All right, and that equals, I'm putting 1, so 1 squared is 1. This becomes 2a, so 2a, but I know a is 1, so it's actually 2 times 1. It's 2a, but a is 1. All right, and then I'm going to have, remember x is 1 there, so I'll put 1 here. That gives me b plus c, but c is 2, so this is b plus 2. All right, into 1 plus 1, so b plus 2 into 2, like that. All right, and if I simplify that, that should give me the value of b. Clearly, we can see from here that b, 4 there cancels with 4. 2b is negative 2, and so b becomes negative 1. I've found my values of a, b, and c. A is 1, b is negative 1, and c is 2. So now I can write my integrand there using the partial fractions we decided, or that we chose. So there we go. That was the first one, and that's the second one. So we know the values of a, b, and c. But before I do that, I can split this further because we know a plus b over c, or whatever is in the denominator, can be expressed as a over c plus b over c, right? A plus b over c plus d can be expressed as a over c plus d plus b over c plus d. So because of that, I can choose to split this second partial fraction further And that just makes the process of integration much easier once we start integrating. Right, so we're going to try and split that into two parts, so like that. So the first term there, the second term is going to be b plus bx over 1 plus x, and plus c over 1 plus x squared. So that's x squared, right? So now we have three fractions. So the original fraction has been split up into three fractions. That's what we mean by decomposition. And now we can plug in our values of a, b, and c, and we will end up with, let's get rid of the numerator at the top there and push that slightly up. And so we can now substitute our values of a, b, and c. We end up with we are going to integrate in one line. So we end up with integral of this dx. A is 1, b is negative 1. So instead of putting plus negative 1x, I'm just going to put negative x, positive x here now. So we'll write minus x over 1 plus x squared. And c is 2, so we write plus 2 over 1 plus x squared. All this into bracket, and then we can now integrate this. Now, the reason why we convert this into these fractions is because it is very, very straightforward integrating this. If you've been doing enough integration, then you know you can simply now list the integrals of these. All right, the integral of 1 over 1 plus x is ln of 1 plus x. The integral of this by substitution will give you a half ln of 1 plus x squared, and the integral of 2 over 1 plus x squared will give you 2 arctan x. All right, so like this. So this you do not need to show an examiner. Once you reach this step, you can simply list the integrals accordingly. So the first one gives us that value for the integral. The second term there has an integral of a half ln of 1 plus x squared. And the third one has an integral of twice the 2 you see here is actually that 2 up there. The integral of 1 over 1 plus x squared is arctan x. And then this, of course, plus c. This is the integral of the expression that we were given. All right? Once again, if you have difficulties with this, or if something passed without you understanding, just let me know by posting comments in the comment section, and I'll be able to get back to you with an answer. All right? Thank you very much. Let's go to the next question.